Hello good people, I'm going to demonstrate how to calculate the x and y intercepts. Let me explore an x-intercept example first. We are being asked to determine the x-intercept of a straight line with the equation y equals 3x plus 60. Before I show the algebraic way to solve this problem, I'm going to construct a graph that will help me estimate what the answer should be. You might be wondering why is it that I chose to draw quadrant 2 of the Cartesian plane. It has to do with the information contained within this equation. This 60 gives me the point of the y-intercept. So on my graph, that would be here at 0, 60. The gradient is positive. It is telling me that when read from left to right, the line will be going up. In other words, it will be going somewhere in this direction. Conversely, if I was to extend the line backward, it means that my x-intercept has to be somewhere in the negative territory. And so, as a rough estimate, I might construct a line that looks something like this. Now I'm going to look at the algebraic solution. Recall that at the x-intercept, the value for y is 0. So now I'm going to say let y equal 0 and see what happens. This means I will have 0 equals 3x plus 60. And now I need to do some transposing. Subtract 60 from both sides, which will give me negative 60 equals 3x. Next, I need to transpose the 3 by division, so I'm going to divide both sides by 3, and that will give me negative 20 equals x. Now I can say that the x-intercept is at negative 20. Note that the graphical representation is not necessary for the algebra to work. However, if I have time, I always prefer to create a little graph to get a sense for what the answer should be. Now, let me look at an example for calculating a y-intercept. We are being asked what is the y-intercept of a straight line that passes through point 26 and has a gradient of negative 4. Before I jump into the algebra, I'm going to use a graph to get a sense of what the answer should be. Now you might be wondering why is it that I chose to draw quadrant 1? Well, again, it has to do with the information that has been given to me. Point 26 happens to be in quadrant 1. So it is 2 on the x-axis and 6 on the y-axis. Next, I'm told that the gradient is negative 4. A negative gradient means that my line will be going down when read from left to right. This also means that the line will hit the y-axis somewhere to the left of my point and up on the y-axis. And so if I was to draw it roughly, it might look something like this. Please note, this is not the exact solution. I'm just trying to get a sense for my answer. Now let's look at the algebraic solution. I have not been given the equation for this particular line, but I can use the general equation for any straight line, y equals mx plus c. And now I can substitute with the information that has been provided to me. The question has given me the gradient. It is negative 4. So now I could write y equals negative 4x plus c. I want to calculate c, which means I need some numbers for y and x. Where will they come from? They can come from any point on my line. And luckily, the question has provided me with the point, 2, 6. So I'm going to say use point 2, 6. And now I could say that 6 equals negative 4 multiplied by 2 plus c. Negative 4 multiplied by 2 is negative 8. So I will have 6 equals negative 8 plus c. Finally, I need to transpose the negative 8 by adding it to both sides. And that will give me 14 equals c. And now I could say that the y-intercept will occur at 14, which means the equation for this line is y equals negative 4 multiplied by x plus 14. At a risk of repeating myself, the graph is not necessary. However, it does help me visualize an approximate answer. That is all for now, and I will see you on the flip side.